Okay, we've been working on analytic geometry. That's what we talked about yesterday. I've left the material on the board. And in particular, we're talking about completing the square as a way of graphing hyperbolas, ellipses, circles, okay, and parabolas. So parabolas, circles, hyperbolas, and ellipses. Behind me on the board, I have the work we did on a parabola and its standard form. So we're going to go to that, Ernie, right here. Okay, I'll wait for you to get there. Now, in this case, we talked about having y equals x squared and relocating the parabola at 1, 1. And the argument was the general form is y minus h, which is the x value. I'm sorry, didn't say that right because I was thinking I had an x starting. Y minus k. And then this is x minus h. So I have h and k both at 1. Hence my origin at 1, 1. That's the translated set of axes. Now I'd like to use this idea to graph parabolas in general. So if I were to look at a particular equation, and I'm going to do that basically a combination of paper and the document cam and what I have on the board to make this work. I'm going to start with the following equation. I'd like you to write down y equals x squared plus 5x plus 6. So y equals x squared plus 5x plus 6. That's where we're starting. And I'm going to leave that there. And the equation I've asked you again, and I'll put it on the document cam here just for a moment. And I need to drop it down a little bit and darken it. Okay, this is the equation. Y equals x squared plus 5x plus 6. Now what I'd like you to do is think of that as a parabola, which it is. And I'd like you to try graphing that parabola by completing the square on the right side. So we have x squared plus 5 plus 6. So what you're going to do is bring the 6 to the left side. So you'll have y minus 6. That's your first step. So I'm going to write that out here on another piece of paper. But I want you to start there. And so you're going to have y minus 6. We're going to put plus something equals x squared plus 5x plus something. So coming off there for a moment, Ernie. This is your first step. So you're going to complete the square of x on the right side. Now there's a little wrinkle here because note you have plus 5x. So that's going to create a rather interesting process. Your rule that you're following to complete the square is take the coefficient of x, which is right here. You're going to divide that by 2 and square it. So you're going to have 25 over 4. Okay. So you should have added 25 over 4 to both sides. Okay. Wait for you to do that. And then we're going to rewrite on the right side of the equation a perfect square of a binomial. So I'll wait for you to get to that point. I haven't shown that yet. So you are adding 25 fourths to both sides, and you want then the new equation. This is what you should have had. Negative 6 is negative 24 fourths. You're adding 25 fourths. That gives you a fourth on the left side. Because you added 25 over 4 to both sides. Let's come off there just long enough. I can raise that up a little bit better. Now let's come back to it. There is your 25 fourths you added to the right side, and that gives you x plus 5 halves quantity squared. That's what you should have done. Now my next step, coming off that, I'm going to rewrite it in a slightly different way. This is my new expression. Now the reason for that is that I want y minus k, so I want something with a minus k. And I'm going to try to bring that into a little tighter focus. And this is supposed to be on the right side, x minus h. It's in that form. So I had to have a minus sign, and so that tells me, from what you're seeing there, and I'll slide that up, that tells you that h is equal to negative 5/2 and k is equal to negative 1/4. Is that making sense? Now what does that tell me about this parabola? Its vertex is going to be located at minus 2.5, minus 1/4. That's where I'm going to have this located as a vertex. Any question there as we come off that? Now I'm going to remind you that I'll write the equation here in just a moment and we'll look at it. Okay, let's come back to the document cam. There was my original equation. Now, one of the things I'd like to know is what value of x will give me y equals 0. That is, I'd like to know the intercepts. That's when y equals 0. Let's stop for a moment there, Ernie. I'm off that, and then I'm going to have to drop the camera to get the angle I want. Okay, let's come back. I want to know when y is 0. That's called an x-intercept. Well, if I do that, notice the right side can be what? Factored into x plus 3 and x plus 2. So if that's the case, that says x equals minus 3 and x equals minus 2 will give what? Y of 0. So I have minus 3, 0 as an ordered pair, and minus 2, 0 as an ordered pair. And those are referenced as the intercepts. Now remember, this is for y equals 0. Now, the other intercept I'm interested in is what? X equals 0. So I guess I could put over here, this was when y equals 0. When x is equal to 0, I'll slide this up a little bit more. When x is equal to 0, what is y equal to?
6.
Just a 6. So I have the ordered pair 0, 6. Now, that's the information we have. A 0, 6, we know the curve crosses the vertical axis at 0, 6. We know the curve crosses the x-axis at minus 3 and minus 2. And we know one more piece of information if I can slide this back up. The vertex is at minus 5/2 and negative 1/4. That's the information I have. Now with that information, as we come off there, can we put that together on a graph and get the picture we want? Now, this is just a rough sketch. Let's come to the diagram. This is the x-axis. This is the y-axis. And what I've done is plot those 4 points. Here's your 0, 6. Here is your minus 2, 0, your minus 3, 0, your minus 2.5, 1/4, negative 1/4, and you fit a parabola through there. Okay? Now that's what I'm going to ask you to do for homework with the problems you have for the weekend. So to reference those, to get a handle on that, I'm going to come to page 614, which is at the end of the book. Taking the same idea, we'll just take a look at one of these that has an even number assigned to it. Let me try to see if I can get the problem so it is focused well and looks good. There we go. Let's try number 6. You have x squared minus 4x plus 3 on the right side. So y equals x squared minus 4x plus 3. I want to graph. And I want to do this by completing the square. I want the x-intercepts and the y-intercepts. You're struggling, if you can, to get a maximum of 4 points. Now, you may have less than 4 points. Think of the parabola in standard form, which has just 1 point that it crosses an axis. That's at the origin. So that's the one you're looking at, x squared minus 4x plus 3. That's what we're interested in. X squared minus 4x plus 3. Okay, we'll give you an opportunity to work with that for a moment. Look back at the equation for a moment, Ernie. Your first step, I hope, is to bring the 3 to the left side. That'll make it a minus 3. So you're going to have a y minus 3. So have that as your first step. And as we go along, I'll be working with you in the steps involved. And as we talk about them, I'll try to do as an intermediate kind of solution. Yes, come off there for a moment, Ernie. This is the way it should start. You have y minus 3. You're going to add something on the left, and you're going to add something on the right. What you're doing is completing the square for x. So that means you're going to take the negative 4, divide it by 2, square that. So what are you adding to both sides?
4.
A 4, agreed? Okay, let's come off there. And then let you carry through a few more steps. I'll try to write each of these as we've done them by a new line so that it makes it easier to see. And I'm hoping that you are up with where I'm going to be as I write this next step. I need to see if I can get the focus good on that. Okay, let's try that, Ernie. This is where you should be at this point. Now, one more thing you need to do. You don't want to leave it as y plus 1. What do you want it as?
Y minus?
Y minus k. So you're going to rewrite this y plus 1 as y minus a minus 1. So I will rewrite it. I'll do that in a moment. And this tells me that the vertex then is going to be at 2, negative 1. Okay, so there's my information. So the vertex of this parabola is at 2, negative 1. Remember, this is x minus h here. So this part right here is the h part of the vertex. And this part here is the k part of the vertex. So hk.
Okay, so you don't take the sign in front of it.
Okay, explain that to me.
Well, you're saying that's h. So h would be 2 as opposed to negative 2? Mm-hmm.
Correct, because it's x minus h.
Okay.
If I had x plus 2, then it would be h is negative 2.
Okay.
So it's just 2. Okay. Now, let's come off there for a moment. What is the next thing you want to do? You want to ask, what happens when y is 0? What happens when x is 0? So we want to ask the question, y is 0 and x is 0. So what I will do is first write the equation again so that we can keep it in front of us on the screen. So here's my equation as I come back. Now I want to know what happens as y is 0 and x is 0. So I will say if x equals 0, then y equals what?
3 or 1.
Y equals 3. So my intercept is 0, 3. Now what's my next question? If y is 0. So I put if y is 0. Now if that's the case, I have x squared, so I'll put then, x squared minus 4x plus 3 equals 0. We can do what to that trinomial?
Factor it out.
Nicely, we can factor it, x minus 3, x minus 1. So that says that x could be 3 or 1. So this gives me x equals 3 or x equals 1. So what are my ordered pairs involved? Well, I will have 3, 0 and 1, 0. So there are my 3 points plus the vertex. So I have a 0, 3, a 3, 0, a 1, 0, and my vertex was at 2, negative 1. Question?
Dumb question. What's vertex? Is that
Okay,
the
let's look back
arch
at where the graph
point?
is. Coming back to the board again. We'll come back to that parabola every once in a while. The bottom part of where the parabola touches is called its vertex.
Okay.
So this is the
Lowest
parabola
point.
opening upward right at the moment.
Okay.
So the parabola opens upward, its lowest point in this case, the vertex.
Okay.
The vertex is at HK. So the vertex is your reference point for a parabola. The center was your reference point for a circle. Let's go back to the document cam.
Okay.
Now we want to plot these points on a graph. So at this time, keep in mind we have a 0, 3, 3, 0, 1, 0, and a 2, negative 1. We have 4 important points that we're going to involve. So what I need to try here is a sketch, and we'll try to keep it somewhat neat of what I'm doing. We have an x and a y for our system. Okay, so you basically come back to a coordinate system. You need to label it. So we put in some uniform markings, and these don't have to be done critically. What I'm doing right now is the type of thing in a stat class that I expect to be done very quickly and not make a major issue of it. Now, one of the things that always has bothered me when I ask people to graph, they spend 20 minutes drawing the coordinate system. Sketch it quickly, 2 minutes max, a minute's enough. Get a quick sketch of the coordinate system, use a straight edge. Now we need to plot some points. We said that the intercepts on the axes, we have one at 0, 3. So let's come back to the graph. At 0, 3, I have one right here. I have one at 3, 0. I also have one at 1, 0. Now, if you're thinking of a parabola that opens upward, I think you can probably see where it's going to be. But if we come back to our vertex, it was at 2, negative 1, right there. Now, that's enough to sketch the curve. Now, I'm going to come off that for a moment, because keep in mind, what this has done is set up a new coordinate system. And I didn't manage to do that quite as neatly as I wanted. Let me clean that up for a moment and do the other part of it. Okay, let's see what we have there. This is the new coordinate system, and it's not looking very noticeable there, so let's come off for a moment. What I'm going to try, Ernie, is dropping that down a little bit tighter, see if I can get a little better focus on it. Now let's try it. Now you can see this line coming right up through here. Now that is called a line of symmetry. Okay, so in that sense, if this point right here is going to be 2 units to the left, there's another point over here that's supposed to be 2 units to the right. The symmetry argument. And I don't know that that looks exactly the same distance there. That's supposed to be 2. This should be over about there, I think, so that that distance looks the same. Then you just sketch with a smooth curve and try to create the look of a parabola, and you have the sketch. That is what you're doing in the homework problems. Now that is for a parabola opening upward. We'll talk about one opening downward in a few moments. Now that's a process we're doing. I want to come back to the problem we did earlier, where we had this as our parabola. So we're going to come back to this for a moment. That was x squared plus 5x plus 6. I'd like to show you where I got this problem. It is back on page 336. So let's come off there for a moment. I'm going to show you the problem that was originally involved here. Now, yesterday I had a conversation in the work area outside my office where we chat sometimes. I even get to talk with Sarah sometimes there. Okay, coming back to the book, we had x squared plus 5x plus 6 greater than 0. This was a quadratic inequality. Now we said we wanted it greater than 0. So that was the original problem. I'm on 336 where that section just starts. It's right below solving quadratic inequalities. So let's come off there for a moment. I want to show you what we have done in the past on that, because I want to tie two things together here. And this is one of those spontaneous kinds of lectures that didn't really get planned until that conversation happened yesterday. Here's what you did in the past. You factored the left side. This is a reminder, which is a great review for a test coming up shortly. That was subtle, right?
That was subtle.
Okay, so we have the left side factored, and then I ask for my critical points. Notice at -3 and -2, we get places that are going to define regions for me. So here's my -3, my -2. So I have region 1 over here to the left of -3. Between -3 and 2 is region 2, and to the right is region 3. So what did you do to solve this inequality? What did we do, as I ask you to remember? What did you select?
Oh, the 0.
A region, right? One of the regions. And
Test point, yeah.
Test point. Yeah.
like the origin, 0, 0, we'll take 0 for x. So let's come back. I'm going to try x equals 0. Well, if we do that, there's my choice. Try x equals 0. Let's come off there just a moment, Ernie. I need to get that just high enough that we can see the presentation. Okay. I tried x equals 0, and I asked, if x equals 0, what do I get? Well, I get 3 times 2. That's... Now, the question is, that greater than 6? Well, that gives me greater than or equal to 6. So let's take, in fact, I probably should have taken x at what? That just gave me greater than or equal to 6, and I want it greater than 6. So let's try x at 1. If I do 1, I'm going to have 4 times 3, correct? X at 1, you substitute. Let me slide this back up. If x is 1, that's 4. That's 3. 4 times 3 is 12. And that is going to be greater than 0. And so either way, I wanted greater than 0, not 6. Okay, so either way, I'm in business, right? So I don't need that equal sign there. So region 3 works. So if we look at this, we would argue that everything to the right now, and I'm going to try to make that like we've done before. We're going to put an arrow. Everything to the right here works. And then what do we argue?
Region.
This doesn't work, and then this will work over here. It alternates. Just as a reminder of what happened. And notice you put an open circle here and an open circle here. Now that's just old hat. Nothing's new there. Next step, coming off there. Now what I'm going to do is come back to my graph. What I'm going to ask is I look at this graph we did. Okay, so we come back to that. Here are my regions. This was at -3. This is at -2. If y equals x squared plus 5x plus 6, notice it's positive here. That was your region 3. And it's positive over here. And that was your region 1. And it was negative where? In region 2. So again, this is R3 over here. This is R1 over here. So to the left of -3, y was positive. To the right of -2, y is positive. So if we think of what we see in that graph and what we argued on this number line, we have the same result. Can you now see, in essence, the graph coming down through like this and back up? Same argument. Here's where it was negative, here's where it was positive, and here's where it was positive. Another way of looking at the quadratic inequality. And that's a nice trade-off. So if you are thinking of material on 336, you could have treated those as graphs of parabolas. And that's what we would like to do in the process. Any question in that? I'm hoping that that helps you see those regions a little more effectively. Okay, I'm going to look at a diagram now in the book. We're back to page 614. Okay, here's a neat parabola. And what's different about this parabola?
Opens downward.
It's opening downward, not upward. So the question, if we think of parabolas in their standard form, okay, and I'm going to leave that on the screen for just a moment. I'm going to write an equation. Okay, let's come off there. This is a parabola in standard form of the kind that open up or down. So here's your equation. How do you know if it's going to open up or it's going to open down? And the answer is A. So if A is greater than 0, positive, then what's going to happen?
It's going upwards.
Upwards. Upwards. If A is less than 0, then it's going to do what?
Down.
Open downward. So as an example, simple example, y equaled x squared, you know this was the standard parabola, y equals x squared. How did that one do? It went through the origin and opened upwards. Now, what's a good example of the alternate case? Y equals negative x squared. And it opens downward. Okay, one more comment for you as we come off there. Just as an aside, I'm going to write another equation and draw a different diagram. Okay, here's the new equation. That was in the last test. Because this is what? Not a function. This is the parabola opening to the side. And remember we have the vertical line test? Mm-hmm. So you have a vertical line, and it cuts the graph in 2 points. So 1x has 2 y's associated with it. But notice all we did was trade the role of what? X and y. Okay, so if I had x equals minus y squared, what do you think it's going to look like?
Open to the left. The other way.
Exactly. It just reverses its location, and so we get a parabola opening like this. Again, this being x, this being y, x, y, and so on. And again, that's not a parabola. Let me try bringing that up just a little bit higher. Okay? So, as we...
That's not a problem?
Not a
It's
function.
Okay.
Sorry.
That's
Not
okay.
a parabola in the form of y equals x squared. It is not a function, but it is a parabola opening to its side. Now, let's come back to this graph. This is the one I want to focus on for a moment. Okay? What will its equation be? Well, we know it's going to be y equals a negative x squared in terms of standard form. But where is its vertex? I want to ask the question, where is the vertex on this new parabola? Give me the ordered pair, please.
0, 4.
0, 4 is a correct answer. I hope as you see that, you agree with it. So it is in standard form at y equals minus x squared, but we have relocated the vertex to 0, 4. So let's come off there for a moment. My question, if I take, let's see what I want here. First I'm going to write the general equation. So I have y equals minus x squared. That opens downward, center at the vertex, at the origin I should say. The vertex at the origin. But now I want the vertex where? At 0, 4. That implies, arrow, that h is 0, k is
4.
4. That's where I want the new origin. Now, without going to the board, remember that means we're going to rewrite y minus k equals, then in parentheses, x minus h. So that's the new form.
Squared.
I have the square on it. So what is it going to look like? Y minus 4 equals minus x minus 0. So our equation is y minus 4 equals minus x squared. Make sense? Okay, the only way I know to check and see if it makes sense is have you try one on your own now.
Oh.
Okay, I need to get that large enough so it makes it easy to see. Bright enough that it's... Okay, let's try this one.
Uh-huh.
Okay, this is number 18. I want the equation of that parabola. Now you know it's opening downward. So what is the equation going to be? You have to find me the vertex first. And you can eyeball it. Nice articulate phrase.
Yeah.
Eyeball the vertex. Okay, question then. What is the vertex going to have as an ordered pair?
2, negative 3.
2, negative 3, do we agree? Okay, good. So we come off there. So I'm going to have the vertex at 2, negative 3. And we know the standard form is y equals minus x squared. So this is the information I have. Now what's your next step? Because if you can get that far, you should be home free. You want to identify h and k. See, h is 2, k is negative 3, right? So if you know h is 2, k is negative 3, then there's only one more thing you need to know, and that is you want y minus k equals x minus h, quantity squared, with a minus sign in front of it. This is what I want now. Now you know that k is what? Negative 3, right? Now this, I think, Pam, may help answer the question you were having before. Minus a minus 3.
Okay.
Then I have the negative sign out in front. And the x, and what's the h value?
2.
2, so I just put the 2 in there. And then square that difference. It would be awkward to leave it that way. So as we come off that, I want to carry out one more step. And the new step is going to be, let me write it first and then I'll show it. Now this might be acceptable, although my guess is that's not the way you would see it. So let's have some fun here.
Minus x.
Let's expand it all and get y by itself on the left side, because that's going to become interesting to us. So I'm going to set y on the left side. I'm going to do this in a couple of steps to make sure I don't lose anything or anyone as I do it. There we go. So I brought the 3 to the right side and I expanded the x minus 2 to x squared minus 4x plus 4. Okay? Now the last step. We'll leave that up there and I'll see if I can write it in. Y equals negative x squared. Remember to bring that minus sign through, plus 4x. Then I have what? A negative 4 and a negative 3, which is a negative 7. That is the simplification. Any question? Now we've gone in this direction. I'm going to draw an arrow on here somewhere. Okay, let's look at that arrow. Not as dark as it might be, but I've gone in this direction. I started with a parabola and got the equation. Now what am I going to expect you to do? Start with the equation and work back to the parabola that you could graph having this information. That its vertex is at 2, negative 3. Okay, and it's opening downward, so you know the vertex. And if I slide back down this way, if x is 0, y is what? Negative 7. So we know it should cross at negative 7 on the vertical axis. And then if I set y equal to 0, I'd have to try to factor that silly thing to find where it crosses the x-axis, and that would be trouble. Okay, let's come off there for a moment. Let's go back to the diagram. Now I've mentioned to you we would like ideally what? Intercepts in the x-axis, intercepts on the y-axis. X and y intercepts. But what I want you to note as we look at this one,
Across the X.
okay, there's my graph. Does it cross the x-axis? Not at all. So I would never get an x-intercept, and so if I set y equals 0, I'm going to get something I can't factor. And if I use the quadratic formula, I'm going to find a complex number. So here is, right down here, that should be at -7. I guess, in fact, it would hit right here. It actually doesn't show it coming because it's not crossing there. It crosses right where I have the mark on the book. That is going to be the intercept. Now, the intent of the directions is a little different than I'm going to ask you to do. What you're to determine from here is how many real solutions you have. So as we come to the book, decide from the graph how many real solutions are there. Now the problem we just did had 0 real solutions in that sense. But that's not what I'm really worried about in these problems on 13 through 18. What I'm going to ask you to do is give me the equation of the parabola from the information in the graph. So you have to find where you think the vertex is, and then you have to know the standard form. And so after you find the vertex, as we did in this problem right here, and you find the vertex and you recognize the general form, then what are you going to do? Well, you're going to slide down and you're going to substitute. Let me come off there for a moment, Ernie. You're going to substitute and keep going now as we come back. And you're going to simplify and finally get me the equation the way it would look, y equals something. So in essence, you're starting with the graph and getting me to an equation. Then, if you look at what we're doing on the problems at the top of the page, in number 6, for example, we talked about, we started with the equation and did what?
Graph it.
Completed the square to get the graph. So, to that extent, you have a total of 8 problems where you start with the equation and get me the graph. Well, we've done one of them, so you're down to 7. Then you have 6 where you start with the graph and go to the equation, but we've done one of them, so you're down to 5. So I think that leaves you a full dozen problems you get to do. Now, let's come back to one of these problems and see how it differs so innocently. I'm going to contrast number 6 and 10. They look a lot alike, don't they? A lot alike. Now, it's not just a matter of changing all the signs because you have a negative 4x in both 6 and 10. But what about number 10? What kind of parabola?
Downward open.
It opens downward, and it has a different intercept because when x is 0, y is negative 3. In number 6, when x was 0, y was
Positive 3.
positive 3. That's not the real dilemma that I'm worried about in that problem. What do you do with the minus sign as you complete the square?
Factor it
That
out.
is my question. So as you look at that problem, we have y equals negative x squared minus 4x minus 3. So let's come off the book for a moment. What I want to do is go ahead, put the new equation under the screen, or under the camera. Not under the screen, that would be difficult to do. Okay, there's our equation. So what's our first step going to be?
Factor out the negative.
To factor out the negative, and then treat what's inside sort of as separate from the minus sign. So let's come off there for a moment as I write out that first step. So you're going to have a y, and that's going to equal, and then we're going to put a negative sign, and then a parentheses. I'm going to have the x squared plus 4x. Let's go that far.
No.
Now question, what should I have done with that 3 before I ever started?
Moved it to the left side.
Moved it to the other way, get it in another
So
room.
it'd be 3.
It's causing clutter. So let's come off that, and I'm going to erase where I had the y, and I'm going to redo this in a little different way. Okay, this is where the wrinkle comes in.
Minus
First,
negative.
on the left side, I have y plus 3 plus something. Now, over here, I'm going to put a parentheses here, and I'm going to have to add something right here, but it was what? It's really
A negative.
a negative. Okay, so to that extent, whatever I put in here to complete the square, and that's going to be a 4, agreed? But it was really what?
A negative.
A negative 4, so I didn't add 4 to both sides, I added a
Negative.
negative 4 to both sides. So as I slide over,
Should be 3.
this should be a negative 4 here. And notice on the right side, I don't really think of anything being out here because I added it inside. But the key, whatever you added inside gets a minus sign thrown at it. That's really important. Okay, now what do we do in the right side? We'll just focus there. Inside the parentheses, how are you going to write it for me? Something squared. What are you going to have?
X plus 2.
Is there an agreement to the x plus 2 quantity squared? But I'm not going to write it that way.
Of course not. Because I already wrote it that way.
X minus a minus 2 quantity squared because I want this in the form of x minus h. And the only way I can get x minus h is to have a negative 2. Now, if you want to think of that in a little different way, if that's bugging you, and this is a typical place to get bugged, I want x minus h to equal x plus 2. So this is what I want. So what does that say? I can subtract x from both sides. Minus h must equal 2. But that tells you that h is
Negative 2.
-2. And again, Pam, that's an effort to come back to your question.
Okay.
Does that make more sense now? Okay, let's slide over to the left. Because I really have what?
Y minus.
Y minus 1, so life is good here because I immediately have that k is what? K is 1. I think I can slide that so you can see there we go. Y is -1. No, I didn't say it. Y minus 1 gives you k is 1. I didn't say that well at all. HK is -2, 1. I have the vertex. Right? Now I'm going to slide all the way back up to the top. What can I do for my intercepts? If x is 0, what do I get?
-3.
So when x is 0, y is -3. Is that clear? This is the tough one now. What happens if y is 0? Remember we talk about setting another ordered pair with 0 for y. So that means this whole thing has to be equal to 0. Okay, let's come off there for a moment. That brings up an interesting question. I want minus x squared minus 4x minus 3 to equal 0. Which is rather nice because what can I then do?
Factor out the negative. No?
Well, I could just factor out the minus from everything.
Yeah.
So I have minus x squared plus 4x plus 3 equals 0. And then what? Does that immediately jump at you as a product of binomials without even having to think? Michelle?
Why can't we get rid of the negative
You technically
I
can
know.
multiply both
Negate.
sides by -1, but nothing's gained.
up there at the top?
Whoa, okay, just a minute.
Just to get it out of my
Okay.
hair, because I really don't like the minus sign, and if I have to carry it down.
There's a
it's
difference in what you're wanting me to do on top and what we can do in that last example. Let's come to the top.
Because I keep
Because
wanting
it'd
to
be
get
That
that.
negative up there has to stay. Now you can put minus out in front as we did here, but you have a y on the left side. So you can't throw that minus sign out here. Let's now come off there for a moment, come back down to the bottom with my equation in one variable. This is now equal to 0, and I can multiply both sides by -1 and be done with it. That's a choice. But a negative sign's nice. You shouldn't feel so discriminatory towards it. So x equals -1 or x equals -3. And so what do I have? -1, 0 or -3, 0. And that gives me two ordered pairs there. We had also 0, -3. And we had a vertex at -2, 1. That's enough information to do what?
Graph.
Plot the curve with those 4 points, smooth it out. And again, the reminder, coming back to a graph we did earlier. If I look at this graph from earlier, go ahead and sketch the new coordinate system through the vertex. That will help you see that line of symmetry. That'll help you do the graph. Okay, I've run out of time at this point. You know the assignment. You know the fun you're going to have. It should be a delightful weekend doing algebra.
Okay. Can I just verify that?
Verify the graph?
Assignment. So 13 through 18.
No, 5 through
Right, okay,
18.
okay.
Number 5 through 18, modified directions as per
That's
lecture.
what I'm trying to, okay, so 5 through 12, we can
5 through 12, complete the square and graph the
it.
curve.
Okay, so 13 through 18, we
You start with the
just get
curve.
the equation of the parabola.
Yeah, and you're going to get the equation by noting what standard form it is in and where the vertex is, and then write your equation finally with y on one side.
Okay.
Have a great weekend. We're listening to Santana. What did you choose?
Oh,
Smooth curves.
did you want to
Homework turned in. Please, have a great weekend.